So before the break, we talked about radicals and simplifying radicals, or rational exponents, which is another way to write radicals. So when we talked about it as the nth root of a to the x. This here is the same thing as a to the x over n. The index goes to the bottom of the fraction, and whatever the exponent is goes on top. And we can use properties of exponents to rewrite this in different ways. But this is kind of what we worked with before the break. Now, what we're going to be getting into today and some of this week is solving these equations. Solving equations with radicals. Now, kind of our first kind of course concept we're looking at today, squaring each side of an equation. If two equations are equal, so if a is equal to b, then a squared is equal to b squared. So let's add some numbers. Let's just say x is equal to 2. So if I say x is equal to 2, we're okay saying x is 2, yes? Well, we can also say then it means that x squared is equal to, well, 2 squared, which would be 4. Well, if x equals 2, it also means that x squared is equal to 4. Both of these are true. So we can square both sides and have a true statement. Okay. Steps. So let's start off with steps, kind of how we're going to solve these here. Now, all the steps we're going to look at for this here that we're going to write down is really dealing with radical or equations that have a radical in them of some kind. Now, if we have more than one radical, if we have 2, we're going to want to try to get them on both sides and then follow these same steps. Now, the first kind of main step, if we have one radical, is to get the radical by itself. Our first main step in solving equations with radicals is to get the radical by itself. Now, once we get the radical by itself, we want to take the nth power of both sides. We want to take the nth power of both sides. And after we take the nth power of both sides, we want to solve. And those are kind of going to be our main steps. Now, when we solve, this part solving here, depending on the equation, we won't deal so much with it today, might require us taking the nth root of both sides. Because if the radicals don't fully simplify, we're going to have to probably keep doing this again. Because anytime we have radicals, we've got to take a power, because a square root, if I square a square root, those will simplify. So why don't we just start looking at some of these here. And our first one is this here, the square root of 5 plus, or square root of x plus 5 is equal to 13. We want to solve this equation here. Square root of x plus 5 equals 13. And we want to find the value of x that will make this equation true. So one way we can go about it is just try plugging in different values for x to see what's going to make this true. Or we can go through and solve it. Well, our first step in solving these here is to get the radical by itself. Well, what is with the square root, this radical? plus 5. So we need to get the 5 away. Yes? So we can do what to both sides? We can minus 5 from both sides. We can minus 5 from both sides of the equation. This 5 minus 5 will cancel, leaving us with the square root of x is equal to. Any questions on this so far? Is the radical by itself? Okay, so that finishes step 1. The second step is take the nth power of both sides. So we're going to put both sides to a power, but what power would we use? Square, because if I square a square root, the square root and square would cancel, yes? Bless you. Now, if it had been a cubed root, we wouldn't square both sides, we would cube. That's why I say nth root, because this would work with any root. Whatever the index is would be what we would put both sides to. Because it is a square root, we would square both sides. So the square root and square simplify, giving us x is equal to 8 squared is 64. Now, we wouldn't use plus or minus here because we're squaring a root, yes? Because the only time we really use the plus and minus is when we are square rooting both sides. Because if I said negative 64, well, I can't take the square root of negative 64. We can't take square root of a negative number. So if I'm squaring both sides, we just square it. Now, the square root of both sides, that's when we take the plus or minus. And if we wanted to check it, we could do the square root of 64 plus 5 equals 13. Well, the square root of 64 is 8. And 8 plus 5 is 13. Okay. Let's look at another one here. 3 minus the square root of x equals 0. Now again, we could try plugging numbers in to see what works, or let's just go on and solve it. So our first kind of main step in solving this is getting the radical by itself. So what can we do first? We can minus 3 from both sides, yes. So we subtract 3 from both sides. Well, 3 minus 3 would give us 0. So we have negative square root of x equals, well, 0 minus 3 is negative 3. So since the 3 was with our radical, we had to subtract it from both sides. And we got negative square root of x is equal to negative 3. So is the radical by itself? No, what's with it? Negative 1. So we can divide both sides by negative 1, or we can multiply both sides by negative 1. It will give us the same result. That we have the square root of x is equal to 3. Okay? Now what can we do? We can square it because the radical is by itself. There's no there's not a negative number in front of it. Nothing being added or subtracted or multiplied on the outside. So we can square both sides. And if we square both sides, well, the square root and square will cancel, telling me that x is equal to, almost, 3 times 3 is 9. You're good. 3 squared would be 9. And we could plug it back in and check and make sure, but this would work. That's all we have to do for this here. Any questions on any of this here? Well, we'll look at this here. Does anybody have an idea of what the value of x for this one would be? So square root of x equals 6. X would be 36. Because is the radical already by itself? Well, yes, there's nothing added or subtracted to it, so really square root of x equals 6. We can go on and just square both sides. Square and square would cancel. X is equal to 6 squared. Well, 6 squared is square root of x equals 6 is really saying what number times itself. As we're trying to see what number squared is 6. Square root of what number is 6? Any questions on these here? Are we good with these here so far? We like these kind of here where we just add or subtract and then we get our answer. Square it and get our answer. Okay. We feel comfortable with this here? Yes? Okay, that's the same thing. Okay, let's look at this here. So I feel that y'all are feel comfortable with this here where we just add or subtract, move things to the other side, square both sides, and solve, yes? So would we do anything really different for this here? Well, not in concept, no. Because again, our first step is what? Get the radical by itself. Up to this point, we've really only had to move one or two things, add or subtract, and then we divided by a -1 to get the sign positive. So when we look at this here, how many things do we have with the radical? Because we have the 4, yes, and the 3. Now there is a 2, yes? 2 is inside the radical, yes? So since we have an x plus 2 inside the radical, we're not going to worry about it yet. Because our first main thing is to get the radical by itself. So the x plus 2 inside the radical, that's all one unit. Because the only way to move that 2 out of the radical is to get the radical to go away. We've got to remove the radical first. So let's deal with the 4 and the 3 first. Yes. Yes. It is being multiplied by the radical. Because if we were taking the 4th root, they would write it very small or smaller, and it would be inside the radical. On tests or any kind of assessment that we have in here, if you do have a question like that, please ask. I couldn't tell you if it is the index or just being multiplied. So would it be easier to move the 4 or the 3 first? 3. By subtracting 3 from both sides. Because that will leave us with 4 times the square root of x plus 2 is equal to So we subtracted it, we moved it over. Now again, we've already said the radical isn't by itself yet because we have a 4 and a 3. We only dealt with one of them. Right? Because those two, the 4 and the radical, are being multiplied together, we can divide both sides by 4. Those 4 divided by 4, these here would become 1, leaving us with just the square root of x plus 2 is equal to, well, 16 divided by 4 is 4. Any questions on this so far? So the radical is by itself, yes? Okay, we finished step 1. Step 2, take the nth power of both sides. Well, what power are we going to put both sides to? The second power. because we have a square root, so we're going to square both sides. There's a square root and square will cancel, leaving us with just x plus 2 is equal to, well, 4 squared is. And what's our last step? We need to solve. We need to solve for the value of x. Right, our last step would be subtracting 2 because we get x by itself. We have x plus 2. We need 2. Subtract 2 from both sides, telling us x is equal to 14. And that's it. Any questions on this here? So this here, was it any harder than the ones we did before? Well, no, we just had more steps. And hopefully, as you've seen through pretty much this entire year, Algebra 2 has not been as challenging a subject as what everybody has said it to be. It's been a lot of little easy steps. Yeah, there are a few there. But a lot of this here, Algebra 2 is a lot of little steps. It's a lot of little easy steps from one thing to the next. And how we match it up is just remembering all of those steps. Yeah. Yeah, this one here. This time we have 3 times the square root of x plus 5 minus 1 is equal to 11. Now again, with this here, we need to get the radical by itself. So what's the first thing we can do to get the radical by itself? We can add 1, yes? So let's add 1 to both sides. Because if we add 1 to both sides, well, negative 1 plus 1, these will cancel, leaving us with 3 times the square root of x plus 5 is equal to 12. Because 11 plus 1 would give us 12. What's next? We would divide both sides by 3 because on the left-hand side we do have 3 times the square root of x plus 5. So we would divide both sides by 3 to get the radical by itself. 3 divided by 3 would give us 1, which would leave us here with the square root of x plus 5 is equal to, well, 12 divided by 3 is 4. So we've gotten the radical by itself because there's nothing being multiplied by the radical or added or subtracted to it. We just have the square root of x plus 5 is equal to 4. So that takes care of step 1, getting the radical by itself. Our next step is to take the nth power of both sides. Well, what power would we put both sides to? The second power, because we have a square root. So we're going to square both sides. And the reason we do this is because the square root and the second power will simplify, leaving us with x plus 5 is equal to 4. Okay, what do we need to do next? Right, solve for the value of x by subtracting 5 from both sides, which tells us x is equal to what? Thank you. Yes, I didn't. 4 squared would be 16. Now we would minus 5. Thank you. And we shouldn't get negative 1. We should get what? 11. That makes a little more sense. Any questions on this here? It is possible to have a negative value for x. We just cannot have a negative value as the square root. Because, so here, plugging a negative number in for x could be fine. Because if, say, it was -1, well, -1 plus 5 is what? 4. It gives us a positive number. We can take square root of 4 and we're good. Now, if this had been -6, well, -6 plus 5 is -1. We cannot take the square root of -1. You all kind of see the main difference between those two? And that's where checking is good. So we good with this here before we move on? Yes? We'll do it. Let's do it. Square root of x plus 4 plus 7 equals 11. Right? The first main step is we do need to get the radical by itself, so we would subtract 7 from both sides because we need to get the radical by itself. These here would cancel, leaving us with the square root of x plus 4 is equal to 4. So what would we do next? Put both sides to the second power, because a square root and a square will cancel, leaving us with x plus 4 is equal to 16. We're almost done. Then we would subtract 4 from both sides. And we get x is equal to 12. I have a feeling you got 0.
Because I did the same thing in the video, and I think, it would have been funny too.
Right, it would have been funny if it was 0. Or if it was -4.
But I really
Yes. So any questions on how we do problems like these here? We're good with these here? Yes? Okay. Let's see what is. Okay, these here look like they're a lot more challenging, yes? I think these are easier than what we just did. Now, here we have radicals, yes? On both sides. Now, whenever we deal with this here, radicals more than 1, specifically 2, if we have 2 radicals, we want to get them on opposite sides. No matter what else is going on, we just want to get the radicals on opposite sides. So here, we do have 2 radicals. Are they on opposite sides? Yes? Now, like we were doing before, we want to get the radical by itself. We're not too worried about that when we have 2 or more. We just kind of want to get them on opposite sides. If we have 3, we'll do 2 and 1. If we have 4, we'll do 2 and 2. We just kind of want to even it up as best we can. So here, we do have it already, 2x minus 1 on one side. And over here, we have x plus 4, yes? And really what we're wanting to do is we're wanting to try to simplify these radicals as best we can. Well, they're both square roots, yes? So how can we simplify a square root? We can put both sides to the second power, yes? So let's see what happens. Square, square. Well, here the square root and square, it's the only thing there, yes? So these would, over here is the same thing, it's by itself, so it would simplify out, yes? And the reason this works the way it does is because each side only has a radical. There's nothing else with it. So these cancel, leaving us with 2x minus 1 is equal to solve for the value of x. So we can add 1 to both sides. So the real nice thing with this here is because since there's 2 radicals and there's nothing else added or subtracted, we can get them on both sides, square it, and the radicals go away. And then we're just really solving the equation, 2x minus 1 equals x plus 4. Add 1 to both sides, subtract x, and we get x is equal to 5. And that's it. If we plugged it back into our original statement, we would see that we get the exact same thing. Questions on this here? 2x minus x, 2x minus, or 2 minus 1 is 1. You're good? Let's look at another one. Let's look at this one here. Now, if we have 2 radicals, we really want to get them on opposite sides. If we have 2 radicals, we want to get them on opposite sides. And really, a radical is any of these here, square roots, cubed roots, fourth roots, any type of root is considered to be a radical. It's in the family of radicals. Now, this here, we do have 2 radicals, and they're on opposite sides, yes? So we're good. Now, since these are both square roots, or we have square roots, I'm going to put both sides to the what power? Second power. So we're going to square both sides. Now, we look at the left-hand side. We have the square root of 4x minus 3 squared. So we're multiplying it by itself. And since it's the only thing there, the radical and the square would cancel. The same with the other side. Now what this will leave us is 4x minus 3 is equal to x plus 9. Now, even though both sides do have, like we have 4x minus 3 and x plus 9, there are more than one term there. They are grouped by the radical. So when we're squaring both sides, we only really have one term on both sides that's being squared. The radical of 4x minus 3, that is 1. And the radical of x plus 9, that is one term. So when we square it, those will simplify. Because if we have more than one term, we have to multiply it by itself. It doesn't work that nicely. Okay, well now we just need to solve for the value of x. So what's the first thing we can do? We can do what? We can add 3, yes. We can add 3 to both sides. There's negative 3 plus 3. These will cancel, leaving us with 4x is equal to x plus 12. Then we can minus x because we're trying to get the value, all the variables on the same side. Solving for the value of x. Because we added 3 to both sides to get the numbers on one side. Subtracted x to get all the x's on the same side. Bless you. Divided both sides by 3. And we get x is equal to 4. So really, once we squared both sides, we went back to our multi-step equations using addition and subtraction to get variables on one side and everything else on the other. Then solve for the value of x. Questions on this here? We like these here? Bless you. All right, let's look at this here. So what's different for this one here that we didn't have on the last one? Is equal to 0. Both radicals are on the same side, yes? We need to fix it. We need to get one radical on each side of the equal sign, yes? We can add the square root of 4x minus 7. We can add it to both sides to move it over. Just like we can do it with numbers or variables, we can do it with radicals. Because those will cancel, leaving us with the square root of 3x plus 1 is equal to the square root of 4x minus 7. We can add it to both sides. Well, now this is exactly like the problems we just did, isn't it? So what would we do next? Square both sides, yes. You're good. We would put both sides to the second power because since these are square roots, when we square a square root, the radical and the square will cancel. And again, this works this way. We can just mark them out because we only have one term on either side. We just have that square root on either side. There's nothing added or subtracted outside. So what that leaves us with is 3x plus 1 is equal to 4x minus 7. So what can we do next? Minus the 1, yes. And if we minus 1 from both sides, we get 3x is equal to 4x minus 8. Any questions so far? What's next? Subtract 4x. Yeah, I knew what you were saying. This 3x minus 4x will give us negative x is equal to negative 8. So we really don't want to know what the value of negative x is. We want to know what the value of x is, positive x. So we can do what to both sides? We can divide by negative 1, or we can multiply by negative 1. Either one will give us the same result, that x is equal to 8. X is equal to 8. Any questions on any of this here? The cubed root of 5x minus 2 is equal to 12. Yes. %. Because the radical is by itself. Yes, the cubed root of 5x minus 12. There's nothing added or subtracted with it, that cubed root. Correct? So, well, wait a minute, we only have one, so these kind of steps that we did at the beginning of this lesson still work. We got the radical by itself, yes? Take the nth power both sides. There's a reason I didn't say square both sides, nth power, because here, squaring a cubed root doesn't work. We can't square it, we have to cube it. So we would cube both sides. Because the cubed root and the cube would simplify out leaving us with 5x minus 12 is equal to, yes, thinking ahead, thinking too far ahead. Now we just need to take the cubed root, or cube 12. 12 to the third power. Because I do know 12 squared. 12 squared is 144. It is what? 1728. 1728. Because at this point here, we can just try 12 to the third power into the calculator, or do 12 times 12 times 12, which would give us 1728. Now what can we do next? Yes? Almost. Add? Yes. I have a feeling that's what you meant.
Yeah.
So give us 5x is equal to 1,730. And lastly, we divide by 5. Yes. 306? 346. 346. And that's it. Well, is that there too much different than what we did at the start of class? No, instead of squaring both sides, we cubed it. We cubed it. And we would do the exact same thing for these here. Now, one thing to be careful of and look out for is if we get the radical by itself, let's just say 6x minus 7. Will this here have a solution? Can I take the square root of a number and get a negative? Well, no. Because when we went over this when we talked about quadratics, where we're talking about the square root of a number, what number times itself gives me a negative, well, we had to come up with one. We had to come up with this imaginary number for this to work, yes? So whenever we're solving, if we get a even root equals a negative number, it's not going to work. Because we cannot have a negative number inside the radical. We cannot take the even root of a negative number. There's just going to be no solutions. Now, odd roots, cubes, third roots, fifth roots, seventh roots, that's fine. We can take the odd root of a negative number. We cannot take the even root of a negative number, which for us here is not too bad. But once we start getting more farther into solving, we're going to have to check and make sure the roots do not have a negative number. We cannot have a negative number inside of a root.